Hey everyone, in this series of videos we're going to see the chapter 1 of Newtonian mechanics and its introductory ideas. Now in this first video we're going to look at the introduction of mechanics, what the word mechanics is and how it was developed and what are the things in mechanics we'll see in this sub-chapter. Now in this subchapter introduction, let's first see the word mechanics. So word mechanics is a branch of physics which deals with physical objects in motion and at rest under the influence of external and internal reactions. So basically in mechanics what we see is the motion of the macroscopic objects and their equations. Now you might wonder how mechanics is there. So the mechanics is since as very ancient times, since our very old young civilizations, what they used to do is they used to observe all the motion of the planetary motions, and then they used to formulate the theories around those, and some of the theories were wrong and some of the theories which were revolutionary also at that time. So basically the mechanics was first developed as a observational science, but from the time of Newton all the theories of the classical mechanics were started to shape as a mathematical operations, and they also had started to gain their mathematical importance. And when Newton formulated his Newton's laws of motion in 1687, and not later from that, his other successors such as Lagrange, Hamiltonian, D'Alembert also developed in the field of the classical mechanics, and they came up with we can say that was another type of the classical mechanics that we say as the analytical classical mechanics. So basically all those successors have also developed massively the mathematical side of the classical mechanics. Now after a long time we were using all those theories, but in 1905 a patent clerk named Einstein released his papers on special theory of relativity, which changed the course of the classical mechanics, and Einstein in his papers proved and described that that space and time are not to be considered as constant, and so we then had a you may say that it was a hybrid branch of the classical mechanics, and it didn't follow many of the previously taken constants of the classical mechanics. So basically special theory of relativity, you may say that it got from that Einstein got his ideas from the classical mechanics and then developed the theory of the relativity, and it was a part of the classical mechanics. So the relativistic mechanics, which was developed by Einstein, yields the results of Newtonian mechanics at relatively low speeds. So we may say that after Einstein developed his special theory of relativity and general theory of relativity, the Newtonian mechanics, or you may say that the old classical mechanics, became a sub part of this relativistic mechanics developed by Einstein. So however, the relativistic theory of Einstein doesn't modify the classical ideas regarding the basic nature of matter and radiation, and hence it is often studied in classical mechanics. So basically it was inadequate to and the other shortcoming of the classical mechanics was that it was inadequate to describe the behavior of particles of microscopic size. So because many of the results of the classical mechanics, such as conservation, the motion of the particles, their equations were not valid when we see the results of the quantum world. So it was inadequate to describe the behavior of particles of microscopic size using the classical mechanics. So it was the second shortcoming, and the first shortcoming was that the special theory of relativity made some serious changes in the classical mechanics and had showed some flaws in that. So basically it was the first shortcoming of the classical mechanics, and it was the second, that is that we couldn't explain some of the quantum we couldn't explain some of the quantum things using the classical mechanics theories. But many of the results of classical mechanics, such as the conservation laws of energy, linear momentum, and angular momentum, are of universal validity even in the relativistic mechanics and quantum mechanics. So it was all about the introduction of this chapter, the introductory ideas of Newton and classical mechanics, and I will see you in the next video with another subtopic, which is the space and time and the theory of the frame of reference. Thank you.